Good morning, everyone, and welcome to the virtual learning course, Performance Measures and Data Frameworks for Geospatial Business Intelligence. My name is Taylor Wells, and I will be your moderator for today's session. This presentation will be provided via both audio and web conference. As a reminder, today's session is being recorded, and all participant lines will be muted. This program will last approximately 1 hour, including a Q&A session at the end of the program. If you have a question at any point during today's presentation, you may submit it via the Q&A button located at the bottom of your screen. Please note that we will send all attendees of today's presentation a certificate of completion via email that you can use for self-reporting purposes. And now it is my pleasure to introduce our speaker for today, Chaz Mateer from Timmons Group.
All right, thank you, Taylor. Thanks everybody for joining today. Looks like we have a pretty good group. I'm glad we can still do these trainings and everything remotely during the quarantine. I hope that everybody is safe right now. I'm going to be talking today about performance measures and data frameworks for geospatial business intelligence. So kind of wanted to take an opportunity to share a little bit of work that myself and my colleagues have been doing with Timmons Group, working with some of our clients on some of these types of projects, and share some lessons learned, best practices on those. So real quick, like Taylor said, I'm Chaz Mateer. I'm a GIS application developer here at Timmons in the Geospatial Enterprise Solutions Group. And so mostly I work on developing geospatial web applications and data products. Do a little bit of data engineering and data visualization, things like that. And I get to work with a lot of our data architects and data scientists and things like that. And so hopefully I'll be able to kind of share a little bit of that perspective too, through this presentation. So kind of the goal for the talk today will be to go over kind of the what of business intelligence and data frameworks, what those are, and then also the how of how do you achieve that through people, process, and technology. And the idea will be to kind of have some case studies interspersed throughout. We'll mostly be looking at kind of some of our local, state, and a little bit of federal government clients, and I'll try to sprinkle those in just to kind of give some real world examples of kind of how how some of this all fits in. And with the intros kind of out of the way, I'm going to cut my video just to kind of save on some of the bandwidth on the screen share, and we'll be doing a little bit of demo stuff a little bit later as well. So just to kind of start things off with a little bit of a formal, I guess, definition of business intelligence, a technological process for analyzing data and presenting actionable information to allow individuals across the enterprise to make informed decisions about the business. So it's a little bit jargony, but I think it kind of encapsulates the idea pretty well. Another way that I kind of like to look at business intelligence in kind of a more simplified approach, right, is like we're tracking data, or we're tracking our accomplishments in some way, and then we want to be able to see those in some kind of dashboard, right, or some kind of visually compelling way that's updated over time is kind of the critical piece, right? That we can kind of see trends in the data then, so we can say, okay, are we trending upwards? Are we trending downwards? Do we need to take corrective action somehow? So something to drive some kind of action decision. Another way I kind of like to look at it is for business intelligence is like, what do I want out of it, right? And I want data integration from multiple disparate sources of data, internal data and external data, from different systems. Maybe I'm pulling from different database connections. Maybe I'm pulling data from web services. They all have different schemas and different data standards and things like that. And I want some system that's going to be able to do that, mix up the data, and then allow me to kind of have these kind of tabular reports and data visualizations and maps, the things that I really want to get to. So, here in this kind of simplified diagram, on the left side, I've got sort of my, what you can assume is like the transactional data sources, right? In this case, I've got some examples of what those might be in here: treatment data, cost data. It could be, what have you, including your enterprise, geospatial data. And then you're going to have some kind of, ETL process, and exchange, transform, load. And in real life, this would be probably most likely multiple different types of ETL pipelines here. But the idea is that I want to transform these data. I want to handle data anomalies, data issues, data quality issues. I want to be able to deduplicate data once I've joined it together with other systems and put that into a kind of a format in some sort of like a data warehouse where, unlike a transactional system, my data warehouse is specifically designed, its schema is set up in such a way that's optimized for, doing the stuff on the right side there, getting the tabular reports, doing quick queries for data visualizations and maps, and, being able to kind of mix and match the data a little bit better. And so that's kind of the, what do I want, and then how do I want it, right? So, near real time, or at least scheduled. It doesn't always make sense to have fully, NRT data for everything, but the idea is that I want kind of in an automated fashion for the data to be updated over time, so that and it's kind of in this repeatable fashion as well, where as new data is coming in, I know that it's flowing in and going through all my same processes. Self-service and pre-generated. So there's a lot of great tools out there now that'll help you out with this. A lot of great BI tools that will kind of give you that self-service platform. So once you can get your data into the format that you want it, to be, you can, basically let some of your business users and even, some of your maybe non-technical users, hop in there and create some of their own analytics and, answer some of their own questions. But that's not to say that you don't just let them out, totally on their own. It's good to have some pre-generated things as well. One of the things that we do often when we, get into an engagement with a client, and we, one of the questions we'll ask first is, what are those questions that you're getting asked every day, every week, all the time, either, internally, operational questions, or questions from like members of the public or something. Those are really good candidates for something that you might want to have a pre-generated report, or a visualization at the ready that you can post on your website, externally or internally, and then those questions are ready to be answered, and you save your staff's time from having to hunt down those answers to those questions every single time. Interactive, that's certainly a given. Kind of in this day and age, everyone wants mobile responsive applications and fully interactive and data driven and whatnot. And the good news is there's a lot of tools, custom and consumer off the shelf COTS, to help with that, to really make some pretty compelling visualizations that are fully dynamic and interactive in pretty short order. Automated and repeatable, I kind of mentioned that a little bit earlier, whereby this gets back to the idea of wanting to save your staff time, not having to do manual data grabs every time there's a question, lean on the technology to, automate those ETL workflows, and have some quality gates and checks in there, things like that. And that gets to my last point, and it's just probably the most important, but having, accurate data. And if you can have these, data pipelines constructed in such a way that you've got metadata about them, you can kind of audit them. Anybody can hop in and see what's going on. Anybody with kind of some technical skill can see what's going on. It's not just some random script that only one person knows how to work with. There's tools to help you kind of with that process as well, and it helps with the data accuracy. So the end goal, or kind of the ultimate goal with business intelligence, right, is like I have the people, methodologies, applications, and tools to pull this thing off. And unfortunately, what most people see with business intelligence is kind of the flashier stuff at the top, like the visualizations, the reports, all the things that you get out of it. But it takes a lot of work under the hood, a lot of data processing. I know I've got a lot of fellow GIS folks on the call here, and I mean, any kind of mapping project that you hop into, 80% of your time you're spending kind of wrangling the data. So here's just a couple of buzzwords there of different types of things, ETLing, batch scheduling. If you're dealing with like PII or something like that, you're going to have to consider masking and encoding of data as well, things like that. And then, where does the geospatial fit in? And again, with a bunch of fellow GIS folks here, we all kind of know, right? Spatial is special. We've got our own kind of storage formats that we have to worry about, as well as our own analysis methods that we might want to include in those pipelines, particularly when we want to mash together, tabular data with geospatial data. And if those tabular data don't already have some sort of geography tied to them, we have to use some sort of, spatial analysis methods that we might want to pull those data together. And then, of course, visualization as well. We have mapping, and we have to take, our systems that do the mapping have to take into account spatial reference systems and things like that. One real quick note, again, on storage, on GIS storage at least, I was talking about kind of disparate data sources. That's pretty common in our world, right? Where a lot of times we're pulling web services or something from maybe a mission partner or something. And we don't want to duplicate the data that they're putting out. So we've got the web services. If we're lucky, we've got an enterprise GIS system where we've, like an RD, it's sitting on like an RDBMS, and that's pretty easy to kind of start to mix and match with other SQL data and join in that way. And if we're unlucky, and probably more often than not, what we're having to deal with is rogue shapefiles just hanging out on the hard drive somewhere. And it's a real challenge to think, okay, well, how can we get these data into a system in a reliable way? And it's really tough to do. It's really more of kind of a sea change is needed in terms of data stewardship and how data is treated more like an asset, to be kind of put into these more standardized systems, something like an enterprise GIS, so that then it can support the entire enterprise, in sort of a BI platform. So to kind of bring some of those topics together and kind of help visualize some of those things that I was just talking about, is kind of the concept of the data framework. This is an example of a client that we worked with, Washington Department of Natural Resources, DNR, in their wildfire division. And we try to kind of plug in some of their systems into this kind of hierarchy, right? So you've got down at the bottom, kind of that operational data. Those are those transactional sources. You can see there's federal systems. These were systems that they, DNR did not have access to over their quality, the data standards, schemas and things, and they had to adapt to how they were pushing out data. And they had their DNR-wide systems, and then also their program-specific systems in the wildfire. And these are tracking things like cost of wildfires, resources, in terms of trucks, equipment, as well as people and where they were going. And how all that played together. And so, the idea would be that gets pulled up into this kind of data warehouse tier. And there you can see kind of there some of the concepts I've been talking about, right? Tracking metadata about how those data are being pulled, storing those in such a way that it's optimized for query performance. And then you've got that kind of layer of analysis that you can do on top of that data warehouse and pull it into this data visualization tier, the tier that everybody wants to be at, and then have some sort of at the end users tier there, have some sort of like a web portal or some way to dole out content to people, and share this information. I'll kind of give some examples of some of those, kind of like that web portal concept a little bit later as well. First, though, I'll hop now into a little bit more of a kind of a demonstration, a little bit of a case study on working with National Association of State Foresters. We've done a lot of work with them over the years, and particularly around their performance measures and trying to kind of help tell a story around the work that they do, sift through a lot of their data to get at some compelling visualizations to help tell a story. So the idea of the story framework comes up whereby you take a look at the landscape and prioritize your investment. In this case, we're kind of looking at more like wildfire management type things. So where are the most prone areas for wildfire? But this prioritization can go a lot of ways. It's just kind of a conceptual here. And actually, I think I'll probably have some time to demo some of this stuff on using a little bit different type of prioritized landscape as well. But the idea is you get kind of a low, medium, high, right? And then you actually do work and you track it and your systems in a kind of a convenient way. And then you can show an outcome, right? You can say, I am impacted the landscape this way. So one of those stories that we were working with them on was building capacity with the fire department response areas that are most at risk. So looking at the kind of underlying burn probability data, and also looking at where funding is going. And the idea would be you'd think that if funding were going to the most at-risk departments, they would have the training, the equipment that they need to kind of be able to respond better as needed to wildfire. And this is kind of I guess a simple example, but we thought this initially that this would be a very straightforward task, right? We've got we can do some pretty straightforward spatial analysis to tag those response boundaries with a high, medium, low score using the underlying raster data from burn probability, and we can get the tabular data for how funding is being tracked for those departments. And when trying to do this on a federal level or a national scale rather, it quickly proved to be a lot more challenging than we thought. There were different data standards, things were being stored different ways. Not all these, you see this FDID column here wasn't always being used. We tried to match things through just fire department name, and it was, the GIS data was in different states of quality. So it was a real struggle to kind of get through all that stuff. But and one of the things that we say a lot with our clients when we're meeting on some of this stuff is it's kind of a good thing to bring some of those data quality issues to light and find out where data gaps may be, so that you can alter kind of the source systems or alter your behavior, drive behavior to kind of fix some of those issues. And when you can actually get these data in a way that you want, you can make really compelling results. So one of the things that we did is when looking at like a single state, for example, it's a whole lot easier to start to pull some of this together. You're dealing with all at least somewhat kind of the same data standards. And so when you actually can pull some of it off, we can tag in there so you can see like that high, medium, low color ramp, as well as the green dots. So the larger green dots is where there's more funding going, and then that roll up number there up at the top, 87% for state of Washington, is 87% of funding for this given year that we were looking at the data went to the high and medium fire districts. So that's a pretty compelling story to tell. It took a little bit to get there, but we actually did a follow-up project with Washington, a little bit unrelated to this, but and kind of went through some of their data and tried to pull off a number of different measures and kind of create dashboards from their systems. And one of the things we did was revisit this concept, and I'll actually pull it up here. We were able to get legacy data as well. Let me make sure that this is up here. Pop this out. Hopefully Tableau will cooperate with me. I might need to reboot it. Okay, so taking that static graphic and basically defining a way that we can take data for a single year and organize it in such a way that then we can populate it with this dashboard. Then we were able to take previous years and populate a number of different years worth of data in there. So here you can see now we've got an interactive graphic. We can change, if I wanted to go to say 2016. We have the data now in here from 2016. I can hover on any of these districts and get a little bit more information about them. I can hover on the funding for those. And I have this time series now that I have those 3 different categories and can kind of see over the years, what were the trends of where funding was going amongst these categories. And maybe I just want to look at the top 2 categories here in this stacked bar chart. It'll filter my map for me. So, it seems pretty simple, but kind of the workflow of kind of stepping through, getting the data prepared, and then being able to reuse that methodology, some of the things that we scripted out to pull in other years worth of data and then display it in this way that then, users can come in, slice and dice it, they can analyze it themselves, is a whole lot more compelling in this, kind of interactive format. So I will show kind of now another example from Washington DNR. Let me see if I can pop this up here on the screen, make it full screen. So again, the project that we were doing with them was a little bit of a kind of a pilot. So excuse some of the kind of draft kind of names on some of these, but the real point of the exercise was to take data from a number of those source systems, follow the data through the system, figure out what we need to do to clean it, figure out what we needed to do to get it in the format that we wanted, and then just at least show it what it could look like in a data visualization. So here we're looking at cost data, and this was a real tough one for Washington DNR. And I'm sure a lot of folks as well. But when tracking wildfire costs, you get kind of estimates pretty quick, and then the actuals are kind of lag behind a little bit. And so there's different systems that are tracking, one, spatially, where are the wildfires occurring? Two, how much did they cost? You have to pull from HR systems, you have to pull from these equipment systems and things like that. So this was it was a real fun and interesting data challenge, and I think had some pretty compelling results. And we were actually able to use those cost data in a number of dashboards. This is just kind of one of them, but we've got this kind of roll-up number up at the top, total cost per square foot. This is actually the median total cost per square foot for a given year. Right now we're looking at 2014. And again, we have this time series. We were able to take that methodology back, clean up some of the legacy data, and pull that in and visualize it in ways that had not been done before. In the blue is the raw number, and then the orange is the cost adjustment, the inflation adjustment there. And so in this middle section here, we have the median cost per square foot by fire reason, as well as by the WUI, the wildland urban interface. It's kind of like a land cover classification. So if I hover over this one, like the one that's pretty high here, non-vegetated, high structure density. It's just different kind of types of landscape around kind of urban areas. So, in this case, lightning really stood out cost-wise that year. So if I click on this guy now, it's going to adjust my other charts. You can see that the trending has changed here. I can look at what lightning was like, cost-wise over the years, and I can see on the map, the dot map here is the size dimension is following the total cost. So you can see this one over in Spokane, the lightning strike, was a pretty large fire. The choropleth here is kind of mimicking what we're seeing here, just aggregating it over a different geometry. And this was, stuff, again, where we added in a little bit of spatial analysis in the pipeline to just tag some of these data with what county they fell into, that kind of thing. And so if I clear that filter, let me see how I'm doing time. Okay. And say, so let's look at 2017, because we can see on the time series here, that one's really standing out. And actually, when we were presenting some of this with Washington DNR, of course, anybody who had worked that year knew off the top of their head, but still being able to, that was a bad year, but being able to kind of see it here is really helpful. And so now we can see different trends down here, and there's a pretty bad vehicle fire that year. Again, in this kind of area here that made that stand out. Real quick, while I'm looking at this, I have a question here from Alexa. How did you choose Tableau for your dashboard rather than Power BI? So, and that sometimes that just comes down to the client. We've used both, and actually I'll talk a little bit about visualization platforms towards the end of the presentation, again, some of the technology stuff. But it can be kind of a tough choice. So like in some cases, like Missouri Department of Conservation is actually one that I'll have some examples on as well. They had a Tableau server. They were training people in Tableau already, and they kind of chosen that as their platform. So we worked within that. If Power BI kind of, usually it might come down to like a licensing thing. It's like which one's more cost effective for you. I think they're both, having used both of them, I like them both. I think they're both pretty. They're pretty comparable. Sometimes I think Tableau has a bit of a better interface, at least to me. That's just a personal thing. And they do kind of tend to have a little bit wider support on spatial data types. They can absorb GeoJSON, shape files, I think CSV. Power BI was a little bit more limited. They could not they, at least at the moment, cannot take shape files. You can do a little bit of workaround with topo JSON actually. But the cool thing with Power BI is they have some integration with ArcGIS Online. So you can have your ArcGIS Online maps in a Power BI dashboard. Some of the way that they talk between the kind of AGOL piece and the Power BI piece isn't as intuitive, but it's pretty cool to be able to just mash those two together, because I imagine a lot of folks will already have AGOL. So thank you for that question. And actually, I do have, while I'm at that, I can kind of bring up another example here. This is kind of off script, but this is a kind of a dashboard of Prince William County inspection data, kind of a demo that we set up for them. This is using Power BI. So I don't have any mapping in this one, unfortunately, so I can't kind of show that off. But it's, again, you can really make some really attractive dashboards pretty easily, and they have a lot of the same concepts, right? Where they have a lot of different data ingestion tools and filters, and it's if you learn one of them, it's pretty easy to kind of hop around and learn some of the others. And so this is actually an example here of where we've embedded it in a custom web application as well. So everything out here is custom, all these widgets up here, and this would lead you around the rest of the website, except for this piece right here. This main bit here is it's Power BI, and so even these data tabs here are just kind of custom things that we built to house this. So it's a good way of kind of showing, and I'll kind of talk a little bit more about that later, but meshing in being a hybrid approach of using the COTS tools to get really attractive visualizations pretty quick, and then tying it in with your existing custom web applications and things like that. So I think with that, if I have more time at the end, I might hop into some more dashboard examples, but for now, maybe I should hop back here. I think my deck, I have to swap this out. There we go. Yep, Washington DNR. So I mentioned Missouri Department of Conservation. And actually, this kind of lines up nicely, because this will be some of the web portal stuff. But we've done similar projects with them, and they've done a lot of work in the BI sphere. And we kind of work with them to clean up some of their data, work through and try to figure out kind of some data warehousing type techniques that we can do. And they've also got this kind of concept here of, and actually I shouldn't have even popped into my slide deck because I need to pop out again. I'll just show you kind of the kind of a mock-up here of what this looks like. But this concept of having kind of a custom web portal that wraps up some of your BI initiatives. And so Missouri or MDC is doing this in line with their strategic plan. So they've got, kind of in their plan, they have this hierarchy of goals, goal 1, 2, 3, MDC takes care of nature, MDC connects people with nature, MDC maintains public trust. And the idea is that, these have some sort of data-driven score underneath, or some way to categorize those made from the data underneath. And this is just kind of a mock-up here, so don't judge them based on these categories here. This is not real data in this instance. Here is just for demonstration, but the idea is that you've got outcomes then in that hierarchy underneath each of these goals. So to make sure that MDC takes care of nature, Missouri has to have healthy land, water, and forests, and they get some sort of, again, data-driven score there. Missouri has sustainable fish and wildlife, they have a data-driven score there, and that's rolling up to make this score. Underneath each outcome, there's different measures as well, right? And that's kind of getting at what we're looking at with Washington DNR things, kind of the base level of data processing sort of. So for instance here, feral hogs eliminated. Of course, feral hogs being kind of a nuisance species that are pretty destructive to the landscape. This is where you would have that kind of dashboard and get that in itself would have its data-driven score. So they have a pretty interesting concept there, and we've been fortunate to kind of work with them on some of this and kind of making this come to life. But the thing that that's driving this is that at the base level, you've got those pipelines that are being able to power these dashboards, day in and day out. And as new data comes in, it's coming in here and populating the system. So a really cool way that they've kind of come up with here to share this information out. And the idea is that eventually this could be shared out with members of the public. For now, it's mostly kind of internal operational, and that's a big thing when thinking about how you do these initiatives, of how you want to frame some of these visualizations of do you want them to look be digestible for members of the public versus in a more operational dashboard, that kind of thing. Now I will hop back in here. Another question here from John. In your web applications, are your methods written in JavaScript with embedded CSS, HTML? Are you linking databases via models and MVC and other? John, a little bit of both, actually, and it just kind of depends on the client. We particularly often, a lot of our applications will be MVC in like .NET and C# on the back end, but a lot of the front end stuff, some of the data processing work will be in probably on the C# side, but most of the front end visualization aspects is going to be in JavaScript. And Tableau, Power BI, they both have pretty powerful JavaScript APIs, just like ArcGIS does. So AGOL maps and things, of course, also will be heavily JavaScript based. And so you can go pretty simple with it if you just want to embed those visualizations. You can, it's a couple lines of JavaScript to pull those visualizations into a custom web app. But you can also kind of go a little bit farther and add in basically kind of event listeners. So when people click on certain things on your website, you can tell the dashboard to do things and stuff like that. Pretty cool possibilities there. And when I talk about tech, I'll mention some more details there and kind of what to look out for in those platforms. Okay, so yeah, just again another kind of just example of MDC's kind of the overall idea. The end goal is it looks like this, but it does take a lot of work to get there. It wasn't overnight. Again, this was just like looking at one measure with MDC. And the question was, where's the customer data stored? Do I have a definitive customer record? And these were all the different systems that housed some form of customer data. So that's it's a pretty monumental effort to kind of pull from these systems and figure out, deduplicate things and figure out what is your total count of customers, things like that. And it all comes back again, this is a more simplified view, but it comes back to that idea of taking data from the transactional source, moving it through the system, mapping the things that you need and what you want, and getting it into that BI platform in a repeatable way, so that you can get at those dashboards, right? And I'll kind of breeze through these since I've shown a bunch, I think already. If we have more time at the end, I can hop into some more of those. But, let's take a drink of water here real quick. So now I'm going to kind of move on to like the how section, right? That was to kind of at least show some real examples of the what, business intelligence and data frameworks, and how do you get to this stuff, and we've learned a lot by working with our clients and how the things that they struggle with and how they've dealt with them and things like that. So hopefully I can share that. But starting with the people, these are probably positions that we're all familiar with, right? And we likely have these in our organizations now. It's GIS manager, analyst, system architect, business users, things like that. Probably some of the things that we don't necessarily have, or that we don't see that are as common at this point, but more and more becoming more common, and really you see organizations that are succeeding in kind of the data landscape and pulling off really cool things data-wise. These are kind of the types of roles that they have, right? So data architect, somebody who's really understands the enterprise data as a whole and can kind of drive strategic direction and like data governance, and can kind of champion the cause of data as an asset for your agency, and really enforce certain behaviors of how data is managed, And it's if when you want to build something or something, they say, okay, well, you can't just go do a manual data grab. This is the process that you have to follow. And if you want to create a new system that's going to collect data, these are the standards that you need to follow, so that we can benefit from the data once it's in the system. Putting data into a system isn't inherently, it's in its on itself very helpful. It's what can we do with it when we pull it out, and how can we compare it with other enterprise data. Data integration lead, that's somebody who's going to be able to design and develop ETL pipelines. Somebody pretty skilled in database management, can kind of help with data warehouse design, things like that, and just most importantly, develop and maintain metadata about those ETL pipelines. Again, so somebody else can hop in there and see what's going on. They know the temporal resolution, when are data being updated, how is it being updated, that kind of thing. Division data liaison is kind of the in-between person between, can speak kind of both the business language and the tech language, and also be a, kind of liaison for external partners as well. When you're asking people for data, it's helpful, to have somebody kind of be that main point of contact who knows the challenges that your mission partners are facing as well, can help pull in data that way. But really, this is kind of the coordinator between business and tech. And I have a good example from MDC actually on that in a bit. And then visualization and reporting lead is the person who can really can use these BI tools to develop these compelling visualizations and be kind of that master storyteller, as well as supervise tech staff to do the same. And so this doesn't have to be, you definitely don't want this to be all one person. I think probably more often than not that kind of happens, where somebody has to try to wear all these hats. But it doesn't have to be a brand new role for each of these. I mean, you probably have staff now that are, have these skills and just need that extra kind of role added on to their responsibilities. But we have seen that it does help, and that some of these are lacking sometimes, and it helps to kind of maybe bring additional staff on if you can to fill these roles and really champion that cause. Which brings me to data champions and data stewards. By working on these projects, we will pretty quickly find, when we're working through with our clients, like who are the real data geeks, and like who wants to, who's really excited about this stuff, about taking data and doing stuff with it. And those are really important to, find in your organization. Somebody who's going to help move this thing along. Is you're going to get in there, and it's going to be kind of disheartening because you're going to like, oh man, this data's a mess. Like I can't make any decisions on this. It becomes tough. And when you have those data champions who are really excited about it and can kind of see the light at the end of the tunnel, that helps to really big benefit there. So on process-wise, you've definitely got kind of concepts like data stewardship programs, data quality assessments. Master data management is a whole school of thought on like the theory of how to effectively manage enterprise data, and there's a lot of good articles out there online about master data management. I would encourage folks to kind of check that out. MDM is definitely helpful when looking at data at a kind of an enterprise scale. But again, I think it comes back to kind of defining those team roles, to have somebody who can kind of own this stuff, who can own the data stewardship program, who can own the data quality assessment and help enforce it as well, and make sure that people are using it and that kind of thing. So one example on process on the MDC side, they kind of took those data team roles and broke out some additional like functional groups for them. And this is kind of a simplified example, but they have a whole interesting like flow chart of when each of these members gets involved in the BI and dashboard development process. But you kind of have these general functional roles, like the strategic planning team is kind of the higher ups who are like, creating the vision of, okay, what do we want to, share with the members of the public, from our strategic plan, what is the measure that we want to show, and then they pass that off to the associated measure owner, so the subject matter expert for that domain, and they're in charge of kind of making tweaks to it and deciding what things should look like. The data owner is somebody who knows where those data live, what systems they're in, Again, MDC is pretty large, so that they've got a bunch of different groups and then central IT as well. So often that ends up being like a database administrator or something, but sometimes it's a technical user who, technical business user or something, who just knows, okay, these data come from some third-party cloud source, or this one's coming from a database, or whatnot. And then you have the BI team who kind of pulls it all together and works with measure owner and data owner to actually create the visualization and create the pipeline and things like that. Another note process-wise is kind of thinking about maturity model and where you stand on some of these things. This is kind of I guess aggressive. I mean, so like on your left side, it's very much an extreme of being totally reactive, totally unmanaged data, all these manual data grabs and things like that. Onto the other side on the right, which is like way advanced, looking at like advanced artificial intelligence and machine learning and things like that. Most organizations aren't at that level and don't really even need necessarily to be at that level, but it is a good thing to stretch for. At least on like the machine learning side and things like that, and it's kind of a goal. And certainly as machine learning becomes more and more accessible over the years, that'll be more attainable, I think, for more people. But really the happy medium, kind of being somewhere in that defined area, is ideal. Having not having to be reactive to things, you're more adaptive to change, and you've got some of these self-service and pre-generated visualization capabilities built in there. So this is just kind of a good thing to kind of look back at. So now I'll kind of hop into and kind of conclude on some of the technology options here. And this is definitely a really big. This is a big area. There's a ton of tools out there that you can use for a lot of this stuff. So I won't go like too in depth on any of these necessarily, but just to hopefully kind of pique your appetite a little bit for some of these and to kind of dig in a little bit further, as you'd like. So on the kind of data storage side, from a traditional standpoint, these are probably going to be what most people are working with, right? Some RDBMSs, SQL Server, Oracle, MySQL, Postgres. And the good thing about these is, again, you probably already have these. You probably already have vendor support. You have licensing for them, and you're already using them. You're familiar with them. Most of these are going to have kind of extensions for data warehousing that'll give you some out-of-the-box functionality to add on, and even kind of walk you through the process of taking data from your transactional Microsoft SQL Server into like a more data warehouse schema, that kind of thing. So a really good option there, and a good way to start. You do though have some cloud options as well, and throughout this technology section, I'll be kind of mentioning a couple cloud options just for those who are interested. And specifically, I'm going to focus on AWS, on Amazon Web Services. There's of course a lot of options with Azure and Google Cloud and Oracle even as well. But you get into kind of the jargon soup of cloud microservices. So to avoid that, I just focus on one here, AWS, which is actually one that we tend to favor here at Timmons. But you've got Amazon RDS, Relational Data Store, which is really just a virtual version of those RDBMSs from the previous page. Really good option there. Amazon S3, you wouldn't think would be necessarily great, but a lot of folks are using it nowadays for what they call data lakes, which is kind of a little bit like unstructured data. So pretty common use case there, and at least in GIS would be for a lot of raster data or something like that, a lot of imagery, tiles, things like that. S3 is really well suited for that. And then you also have Amazon Redshift, which is a specialized database system specifically for doing data warehousing. It has a lot of like query performance enhancements and things there. So overall, you're going to get the benefits with a cloud option here. It's good for prototyping. You're going to get cost benefits. Pay for what you use, that kind of thing. But the downside is it might require a little bit additional training just to get spun up if you're more familiar with some of the traditional options. On the ETL side, again, you're going to have kind of the giants up there. Microsoft SQL Server, the SQL Server Integration Services, SSIS, is a really great option for ETL. Oracle has Data Integrator, There's also ones called Calend, and there's a bunch on here. And even some of the visualization tools, some of the BI tools have some integration or some ETL tools in them as well. Tableau has some, and has a whole lot of data connectors, things like that. But the main thing with these tools, and one of the things is, I mean, you could still custom script your ETL, and some folks do. The thing there would be that you want to have some kind of framework, or in whatever language of choice, like maybe like Python or something, some kind of framework that is specifically geared for ETL, so that you can document those processes, things that can handle concurrent running of some of those data pipelines, can tell you when things like errored out and can log for you, that kind of thing. That's what a lot of these tools here, like with the GUIs in them, will help you do. And they'll give you kind of out of the box tools, as well as the ability to extend with code. With SSIS, you can work in C# and .NET. That's what I have kind of up here. But again, the main thing is that it's repeatable. You can train people on it, and then people can see it and they say, okay, I know how to work in this, and can kind of pick it up and run with it. On the cloud side for ETL, AWS Glue is a managed service, so very cost effective in terms of just pay for what you use kind of thing, and very similar idea for to some of those GUI ETL tools, where you rip through some of your data. It tries to discover the schema for you, and will try to help you out with mapping the data, give you the GUI tools that it can, and then you can export things to Python and tweak them from there if you need to. AWS Data Pipeline is also very similar, but gives you a little bit more control of the underlying VM. So if you really needed to scale the compute power that your ETL pipelines are running on, that would be kind of the better option for you. On visualization platforms, and I've kind of talked about this a little bit as folks were asking, you have a lot of options, and you've got kind of custom options as well as the COTS options, right? So Tableau, Power BI, definitely Esri, Operations Dashboard, and ArcGIS Insights. Like we use that a lot with a lot of our clients on projects. And on the custom side, if you wanted to go full custom, you could do something like D3JS, or if you're working in like the R programming language, we have one of our data scientists loves to work in R, and there's a framework there called Shiny that does applications and data visualization creations. Pretty cool. But of course, on the custom side, it's going to take a lot longer to build some of those out. But on the COTS side, these are the things that you really want to be looking at, for feature-wise on some of these, and you want it to be something that technical users can use and can extend, and business users can use pretty easily. You want a pretty nice web portal for people to work within, as well as web and desktop authoring tools. For publishing dashboards, being able to do them in the web is pretty nice, but the desktop authoring tools for like Power BI and Tableau are pretty great. I mean, they just give you a lot more control for what you can publish out there. Data connectors, being able to connect to a number of different sources, cloud databases, on-premises databases, databases of different types, raw file formats, that's pretty critical. And kind of that self-service piece again as well, right? Like having some, way that users can easily access that platform, and it's pretty familiar for them. And then to that bottom point, which I was talking a little bit about, developer tools and SDKs, software development kits. You get a lot of good stuff out of the box with some of these platforms, but you want to make sure that they have a really powerful developer network and a lot of good documentation. I mean, Esri is a really good example there. Of course, it has awesome documentation. Both Tableau and Power BI have really cool dev tools as well. But you're going to quickly realize, ooh, I'd love to be able to do this. Or your users either are going to say, I'd love to do this, I'd love to do that. So I want to expand that kind of thing. So that kind of brings me to the end here, and I just kind of want to leave folks with the conclusion of treat data as an asset, adopt the process, embrace the tech, empower business users, and tell compelling stories. So with that, I will kind of take a look here. I've got a couple questions on the board here. Another one from John. Did you have issues with standardization and documentation of data collection methods and schema archival strategies? Yeah, no, I mean, for sure. It's a tough thing to do. It's and that's kind of what it helps, again, to have those folks who can kind of own those things. So you've got somebody kind of spearheading the creation of those documents. I'm trying to think of some examples. Standardization and documentation of data collection. Yeah, and it gets into that kind of like when we would start to develop some of those ETL pipelines, just adding additional metadata, right? Of okay, this system tends to have data in this way, and we're going to pull it through this in XYZ way or something like that. Sorry, I don't know if that answers that question well, but it's certainly a challenge, and it's just something we kind of had to work through. Again, from John, take home, it's a lot of work up front and generally a team effort to design a highly functional working database. Absolutely, John. Yeah, no, I mean it's you don't want to just pin it on one person for sure. And another thing that we see a lot is people get really excited about wanting to build to build new systems, and myself as a developer, like I want to build new systems too, but it's kind of I guess just a culture change in the agency where you need to like step back a little bit and say, okay, well, if we're going to do that, what should our data model look like, really? Like there's a lot of great tools out there with like ORMs and things to make database development and things really easy to do, and just kind of put some system together pretty rapidly, and then you're storing data. But it's like, well, we were already storing this data over here. If we had used this as a lookup table and pulled data from there, we're going to make our life easier when we try to pull the data out. So yeah, it's really like adding another level of like kind of review when these systems are getting put together, and saying, okay, when we make this system, we're going to want to be able to pull this data out of it afterwards and mesh it with this one, so it needs to follow these standards. Thanks for those questions. Looks like nothing else yet. I'll hang out here for a little bit. If folks have more questions, definitely shoot me an email if you have any other questions on things. If folks want to chat about things, I'm definitely happy to. I know this is just kind of a tip of the iceberg stuff, just kind of sharing a little bit of info here, but a lot of cool stuff there. Definitely let me know if you have questions. If you guys just want to talk tech or anything, happy to help. And thanks, thank you everybody for hopping on and listening. I hope it was interesting.
Thank you, Chaz. As he mentioned, at this time, we will again be taking questions for our participants. Please use the Q&A tab at the bottom of your screen to submit any last questions. Alrighty, well, Chaz, do you have any additional comments before we wrap up?
No, I think that's it. Again, I really appreciate everybody hopping on and listening today, and stay safe.
All right, awesome. Well, that concludes our online program. Thank you to our presenter and all of today's participants. This program has ended. You may now disconnect.